hands-on activities done. So my name is Parmarat, and I am the Vice President of the Learning and Certifications Group here at Cisco. Just a reminder, some of you may be new, or just a refresher, our charter at Cisco Learning and Certifications is to make sure that we're providing all of you with the skill proficiency needed to be successful in your careers, as well as within the business that you work at, making sure you can do what you need to do to achieve those business outcomes. And we do that through online learning with Cisco U. If you haven't registered for that, I highly encourage you to do so. There's a plethora of information and training inside of that. We also do that through our certifications. And those certifications, again, as a reminder, these are industry certifications. And what that means is they're accredited. We consistently update those to make sure that they're covering this technology as well as the skills that you need to be successful. And we also, before we create a new certification, we do extensive analysis to make sure that the certification that we're creating meets the in-demand skills in the market. And that is why there is such excitement around our new multi-cloud certifications. Cloud connectivity, secure the cloud, and our assurance blueprint that we just announced. So with cloud connectivity, which Quinn is going to go over this morning, this is all about SD-WAN, firewalls, cloud platform tools, and user authentication. I'm sure you're all being asked to look at that and think about that and deliver on that. Our secure cloud access covers threat intelligence, security operations, as well as end user and device security, workload security, application security, and this all comes to converge around the policy needed for things like integration with SASE, Zero Trust, as well as XDR. And then, of course, how do you observe? How do you make sure that there is assurance on that network? This new certification covers that. It covers all the things around using data to be predictive, using data to do data analysis, troubleshooting, as well as resolution. So super excited. We think you'll find these very powerful for your skills and for where you work. The next thing that we're going to cover during the week and is also in Cisco U is AI. AI is absolutely the buzz. And I know you know that we use a lot of predictive AI and ML in our typical Cisco solutions like Meraki Insights, Thousand Eyes Insights, and Catalyst Assurance. But we also have you covered for where AI is going. Within Cisco U, we've created a lot of tutorials, as well as presentations that give you the foundations of what AI is, how to get started with it, how to think about the art of the possible and start playing with it. So as it becomes more mature, you're ready. We also have a couple of sessions in the Cisco U Theater. So we encourage you to come by and look at those and participate in them. I welcome you all. I really am interested in your feedback. The team is interested in your feedback. So please take the time and introduce yourself and have a great week of learning. I'll hand it over to Quinn.
Thanks, Par. Let's flip the screens. Perfect. So I'm going to get this kicked off real quick because nothing is complete without a live demo, and we like to live dangerously, right? So I should be getting a prompt. All right, even better. Live by the demo, die by the demo. Even better. All right. Okay, I'll just flip back over to that in a second. So my name is Quinn Snyder. As Par mentioned, I'm going to be covering some cloud connectivity with our new ENCC certification. So the ENCC, or our cloud connectivity cert, is all about how do we take our on-prem resources and connect them into different and various clouds. So that's your AWS, that's your Azure, your GCP. We do that a variety of ways. We can do that using SD-WAN, as Par mentioned earlier, but we also have to be familiar with our cloud-native tooling. So being able to connect IPSec VPN tunnels from our on-prem routers into our clouds as well. And so that's what I'm going to be covering today. And hopefully, if the automation decides to work, there we go. It's kicked off. If the automation decides to work, we will be demonstrating how we can use some automation as well to rapidly test and prototype and go through some troubleshooting scenarios as well. So you can find me on social at QSnyder, and let's go ahead and get started. So like I said, we'll go over the agenda. We'll talk about the exam topics and what is on the ENCC certification, and as it pertains to this cert. Before I get started, how many folks have been asked to connect something on-prem into the cloud already? How many of you have kind of struggled with various ways of going about doing it, moving the resources, all the routes and things like that? It's been kind of a struggle and exercise as well. So we'll go over what we have put in the blueprint in our exam topics and how we can help make that easier. We'll talk about cloud connectivity in general. Now, if you've messed with multiple clouds, we all know that they're a little bit different. So we'll talk about some of the terminology and where it differs. I'm going to be working with Azure, but we'll be dealing with AWS and GCP, and we have tutorials on that as well. We'll walk through the click ops of how we create that cloud VPN in Azure, and then I'll show the automation, and we'll wrap all this whole thing up. So, in the exam topics, if you've looked at the ENCC blueprint or exam topics, there's two different items that correlate to this presentation specifically. In domain 3.0, there's IPSec cloud connectivity. So you're being asked, how do we connect our on-prem resources via IPSec tunnels to the clouds using their native tooling? So their cloud virtual network gateways or some instantiation thereof. We have to be familiar with and proficient in that with AWS, Azure, and Google Cloud. They're all slightly different, so you need to be familiar with the terminology and the different machinations that you have to go through in order to configure the native IPSec piece there. The other piece revolves around domain 5.0, and that's management. So not only do we have to be able to configure those cloud endpoints and cloud resources, we need to be able to figure out what happens when something breaks. So we have a couple of different items there. 5.1, where we're dealing with the actual IKE connectivity. So our phase 1, phase 2 connectivity, what does it look like when the VPN is broken, whether we have bad security parameters, bad negotiation, bad pre-shared keys, etc. We also have 5.2, which is where we're dealing with the BGP piece. So there's a variety of ways that we can connect and exchange routing information between the cloud and our on-prem. We can do that via static routes. We can do some various things, but we're really focusing on BGP and OSPF in the troubleshooting. So we need to know what happens or how do we tell when BGP is broken between the clouds, whether that's bad AS or if we're doing some MD5 authentication or things like that. We need to be able to understand and diagnose from debugs and show commands what's going on with our routing between our on-prem and the cloud. So a couple of key points. Don't neglect the troubleshooting because that's honestly where things can go wrong. Now, as I said earlier, they talk about in the ENCC blueprint, they talk about 3 different clouds, so our AWS, our Azure, and our GCP. I'm dealing with Azure in this presentation, but it's all about terminology. So when I connect something within Azure to an on-prem resource, I have my virtual network, my VNet, and that's that network cloud entity the LAN entity in the cloud. I have my virtual network gateway, which kind of acts as my VPN concentrator. And then every cloud provider has to have some concept of a local network gateway. That is a virtual manifestation of our on-prem resources in the cloud. We're not just going to accept any connection into the cloud. We can't just put in some parameters and let it connect. We have to tell our cloud provider what to expect from our local connection, from our enterprise or from our data center. So we have to create a local network gateway that provides that information that we can manipulate and deal with to connect those two together. And then finally, we build a connection between our VNG and our LNG, and that's what establishes our VPN or allows our VPN to be created. Now, this is different from AWS and from GCP. A lot of folks are familiar with AWS. They're kind of the 800-pound gorilla. But in that case, we have a lot of the similar concepts, but we're talking about VPCs. We may have to create route tables. We may be dealing with some other things that are slightly different. So it's important not just to say I've dealt with cloud, but I've dealt with this specific cloud. And you have to repeat that over and over because those things are different. Now, our steps in building this whole cloud VPN are going to be the following aside. But I do want to call out up here in the upper right-hand corner, we have a set of Cisco U tutorials that walk through cloud connectivity using the native cloud tooling to on-prem resources, not just for Azure, as I've demonstrated here. We have them from AWS and for GCP. So this will take you directly to the Azure tutorial that I'm demonstrating here, but there's also some for AWS and GCP. Same layout, same format, just for the different clouds. But in our case, to create an Azure VPN, we'll need to start by creating our virtual network. That's our top level construct. That's going to include our Cedar block and our subnets. That's different, again, just to emphasize the differences, that's different from AWS. AWS, I have to create my VPCs, then create my subnets, and then create my route tables. That's 3 separate steps. Azure, I can do it all in one. So again, just the conceptually all the clouds function the same, but the devil's in the details. We have to know where each cloud is different. I'm going to then create my virtual network gateway, which is going to create that VPN concentrator. I'll define my local network gateway. That's my far side. What's the IP address I'm going to be coming from? Where's my connection? What's some of the negotiation? What's my BGP AS? Those kinds of things. I'll then connect those two together virtually and define my security parameters, my IKE phase 1, my IKE phase 2. Also allow BGP because there is some cloud firewalling that goes on between there. If I don't enable BGP in the connection, even though I've enabled it in my VNG and my LNG, I won't get any BGP packets passing between the two. That's that troubleshooting and knowing what steps are where. Then I'll apply a router template, and if everything goes well in this demo, we'll have success. So we'll start off by building a virtual network. So in the Azure portal, we'll create a virtual network by clicking on the virtual network and then create. We provide a name down here. In this case, it's just ENCC testing VNet. We give it a region. Now, I'm using US West 2, but you're obviously going to apply the region based on what's important, or where, geographic location, or maybe data sovereignty or things like that. The step that goes in behind there is, and it'll scroll around here in a second, is about the subnets. So by default, when I create an Azure VNet, it's going to assign a supernet, a Snyder block, to that. By default, it's 10.0.0/16. So I've got /16 that's given to that VNet. But that's just my block. That's where I can actually create those IP addresses. That does not actually create subnets inside of that Cedar block. So the following step, and it'll be coming up here in a second, is actually creating a subnet. Azure by default will pick out the first /24. So we have a 24 in there, 10.0.0/24. It will automatically create that as a default subnet inside of our VNet. So we have a set of addresses. Now you can change that. You can add multiple subnets. You can move those around. But what I said in Azure, we create those automatically as part of our VNet. AWS, we've got to do that separately. We can apply some tagging, and then we'll go through the deployment. And so once that's created, we now have that virtual construct that we can start building our cloud VPN tooling in. Our next step is our virtual network gateway. So this is that VPN concentrator. We'll click create. We have to give it a name and then a region. The important part here is we have a VPN type, and there's several different SKUs that we can assign within that different versions or throughputs within that virtual network gateway. Now you'll see a lot. There's generation or 1 through 5. Those are based on throughput. So 1 being the lowest throughput, 5 being the highest throughput for that VPN. So that's a matter of scale, referencing the Azure docs. The important part is for this tutorial and for BGP connectivity in general, we have to select at least version 2 or higher. The VPN SKU 1 does not support BGP routing. So 2 and higher will enable BGP. Now, at the very end, you may see some others that have an AZ at the end of them. That allows us for active connectivity. So inside of our SKU numbers, our SKU version numbers, which are coming up, you'll see when I click through them, we have VPN GW2 AZ. That says we're going to do active. I don't necessarily care about that for the sake of this tutorial, so I'm just going back to VPN Gateway 2. That gives me the lowest amount of throughput, the lowest cost for the tutorial, but I am enabled with BGP. We assign it to our VNet, and then we have to provide a gateway subnet. So that's a different subnet, 10.0.1/24. Every VPN gateway has to have a unique subnet. We cannot pull out of the default. We have to have our own gateway subnet that's assigned to it. We've disabled active. We've enabled BGP on our virtual gateway and assigned 65.515 for BGP-AS. Again, we have to enable BGP in multiple places. So if we're doing BGP, make sure you assign it accordingly. And then we go ahead and create. The next step is in our local network gateway. So this is that manifestation of the representation of our local network inside of the cloud. So I assign it a region as well. We have to make sure that our regions are there. We give it a name. I'm defining an endpoint. So where's that VPN connection coming from? So in this case, it'll be blurred out. Trust me, it's my public IP address of a router sitting in my house. So I assign the IP address of my endpoint of where that's going to be coming from. And then secondarily, at the bottom here, we're going to be doing a VTI style VPN to establish that VPN connectivity. So the local and the virtual network gateways will connect over IPSec, which is fine. But then I need to have IP addresses or interfaces inside of that tunnel in order to exchange VPN routes. So I used 192.168.150.0/30. So I'll have an IP address that gets assigned to the far end, and then an IP address that gets assigned, obviously, on my tunnel locally on my router. And that's what's going to allow us to exchange BGP routes via that peering. So you can make it as large or as small as you'd like, but you need to make sure that you're going to have that separate address. Now, there is support for 169 IP addresses in there as well if you choose to use those. So you don't have to necessarily carve out separate subnets from your network in order to create that BGP peering. But in this case, I've made it a little bit easier. 192.168.150.0 is going to be that additional, /30 is going to be my additional IP address range. And I'll let that scroll through just so you can see what I'm talking about there. Yeah, like I said, that's my public IP address. And then here in a second, I'll have the 192.168.150.0/30. And if the animations are a little bit small, don't worry. I have a repository of all of them that I'll show in a second. We also need to make sure that we configure our BGP settings. So what BGP-AS is going to be assigned to our local network, and then what is the peer address, or what's going to be the local tunnel side or local my router's IP address inside of that tunnel. So we need to make sure that we assign all those constructs so that Azure knows where we're coming from. And then one thing I've neglected to talk about is as you go through these creation steps, there may be some that allow you to do tagging. So basically, last step of creating tags. I haven't done that in any of these steps, but a good general practice when it comes to cloud in general is saying maybe tagging this dev or prod or certain business units or things like that, so you can filter on resources if you've got a lot of things sitting inside of that cloud tenant. The final step here is creating our VPN connection, and this is where the magic happens. So when I create my VPN connection, I'm going to create my connection type, which is going to be IPSec, and then I have to tie it to, and that'll pop up here in a second. I have to tie my virtual network gateway with my local gateway. So the connection can be between anything, but I have to make sure we're associating the information that we've created in our virtual network gateway with the information that we've defined in our local network gateway. We then create a pre-shared key for that VPN. I'm using IKV2. There's a little check there, enable BGP. So that's 3 places I've had to do BGP configuration. If any one of those is wrong, it's going to fail. I'm creating a separate, a custom IKE policy where I've going through all the drop downs. That's just like the overkill, most secure one. And then that should be, that should be it. Everything else I've left is default. So this is where we talk about the troubleshooting, because there's a lot that can go wrong. Like I said, we've got 3 different places where we have BGP that can be configured or enabled. We have a variety of different phase 1 and phase 2 parameters that we can select and change. And if we've seen this, we have a lot of clicking that can go on. So in a second, we'll talk about how we can automate that. But there's a lot of places, there's a lot of things that can be different. What is a phase 1 failure? What is a phase 2 failure? What does my BGP connectivity look like? Maybe I don't have BGP enabled. Maybe it's wrong AS, things like that. So we've created our virtual gateway. We've created our local network gateway. We've tied them together with our connection, and we have defined our parameters. So all of that being said, everything should be good. But how do we find the information that's important to us in order to build that VPN connection? So Azure hasn't given us any output. It hasn't said so far, here's your public IP address, here's our BGP peering, things like that. How do we find that? So after we've created all this configuration, if we go back into our virtual network gateway and we click on the resource that we've created, down at the bottom, or kind of in the middle, you'll see this configuration tab. That's going to say, what have we configured? But also at the very bottom there, we'll see here's our BGP peer address, and here is our public IP address. In this case, it was a 4 dot something. So using that information, we now have enough to be able to build our entire VPN connection. We have the public IP, we have our pre-shared key, we have our security parameters, and we've defined all the connection inside of our cloud. So what does it look like when it's actually successful? Well, there's two things that we're looking for. A, we're looking for a successful VPN configuration that's being established. And we do that by, it's the overview. I think it says overview. Yeah, the overview tab. Inside of our virtual gateway, so our VGW, we can see we have successful throughput going over that tunnel. So we've established that there's some connectivity, and in case we're passing packets back and forth, but over the tunnel interface itself. The second piece is under the BGP peers tab in the virtual gateway itself as well. We can see that not only do we have a total number, or up here at the top, it's really blurry for me, so that's why I'm going back and forth. Up here at the top, we have who's our BGP peer itself? What are we connected to via BGP? What's our status AS? How long have we been connected? How many routes are we exchanging? The same kind of information that we'd be getting from like a show ID PGP sum or so. And then down below that, by default, it only shows 50 BGP routes. That can be you can scroll to see all, or you can change that in the settings. But that's all of the routes that we're exchanging via BGP. So just as we're seeing the locally connected and all those things that we would normally see in a router, we can see that same amount of information in the cloud, as well as where it's coming from, our AS path, all those different pieces that are important to us when we're troubleshooting BGP. So we now have success. So where's the troubleshooting? So we've gone through this and we've done a very prescriptive, hey, here's how we follow this tutorial. That's great if you are unfamiliar with the cloud. But like I said, domain 5.0 is about troubleshooting, IPSec and IKE, as well as BGP. We need to find ways that we can break that provider's configuration and view the CLI output on our router in order to make sure that we're doing things correctly, or we can see, hey, I see these problems, this is the fix, because you will get those questions on the exam. So that's a lot of clicking, a lot of click and move and this and that and the other. You can edit the configuration if you chose to, but I come from a network automation background, so this sounds like a problem for automation to solve. So what declarative cloud-centric IAC tool could we use to build our cloud for us without having to go through all those ClickUps? If you're thinking Terraform, you'd be right. So I want to show a little bit of Terraform that's also included inside of the repository that'll show up in a second here. And you can see where the things are, the configuration bits and pieces are the same as what we would see in our cloud. So how many folks are familiar with Terraform at all? Heard about it, messed with it, played with it in the lab, kind of like exploring it? So this configuration file is available inside the repository. I'm going through, this is some Terraform top matter about our required providers. We are using the HashiCorp Azure provider. I've given some information of how Terraform is going to connect or authenticate to the cloud. And now each of these things should look very familiar. I have this virtual network. We can see I have an address, a set of address space here. That's that 10.0.0.16. That's there by default. I'm creating some subnets. So in this case, I have that default subnet 10.0.0.0/24. And I'm also configuring the gateway subnet 10.0.1.0/24. Now, if we notice something here, this is very critical. When we create a gateway subnet, it has to be called gateway subnet inside of Azure. Ask me how I know. I built this thing like 50 times last year, couldn't get it to work. Read the docs. Oh, you have to call that gateway subnet. So little bit of trivia there, which also may be a question for the troubleshooting. Someone's messed with the gateway subnet, changed the name. What's going on? Well, it's got to be called gateway subnet. We have our local network gateway. The important settings there is the ASN and our BGP peering address. So again, that's that same configuration that we put in those the boxes down below. We're creating a public IP address. In this case, just say, give me a public IP. I don't necessarily care what it is. Just tell me what it is after it's been created. And that's that dynamic allocation, because I don't have a block that I've registered with Azure. So just give me something out of your pool. Here's my VPN gateway. So I have a route-based VPN, which was what we had before. It's VPN Gateway 2 is the SKU. There's that same ASN 65515 that was there by default when we created the VGW in the cloud. There's that association with the IP address. So our VGW has to use the public IP address that we created. And then finally, here's our connection. So we're enabling BGP. We have an IPSec VPN. And here's all of our different security pieces. And those align directly with what was in the tutorial. So we want to change this. Maybe we want to change the Diffie-Hellman group, or we want to do different integrity or have different PFS groups. All we've got to do is change those values, destroy and apply, and you have a new template, a new cloud instance that's been created, so you can see what's going wrong if I break it. At the very end, I've been nice. Instead of having to go back and figure out where that public IP information is by going back to the portal, which we could if we wanted to, why not let Terraform do the heavy lifting for us? So in this case, there's our public IP address for 155.114.117 and our BGP peer. So we have the same amount of information that we've created. It's been automatic, and I will go back up here. I know it's a little bit hard to read. Minute 40 there. The big piece is the virtual network gateway. It'll create in about 21, 22 minutes, depending on how long it takes. But hey, it's enough time to go make another cup of coffee and go do some troubleshooting. Nothing goes better than caffeine and troubleshooting. So if I have this information, I'm going to go through, and this is also provided as part of the tutorial. I'm going to change this just so you can see that, the proof's in the pudding, nothing up my sleeve. Let's change that. I've provided a pre-shared key. Let's change this. My IP address, change that. And all of this template information should look very familiar. All that should be the same. Okay, let's Control A, Control C. And let me log into a virtual router sitting in my house. And go ahead and paste all that configuration. While that's pasting, I'll go back here. So bringing it all together. This QR code right here is, you can go to github.com/qsnyder/Cisco U1814, or you can use this QR code. This repository will contain a couple of different things. The sample Terraform files that I've shown earlier, so all you've got to do is edit with your tenant ID and some variable stuff. There's a README up there. I will fix that and edit that over the next day or two with how you actually use it. But all the information is there. It's going to have a PDF of the presentation, so you can reference that. The problem with the PDF, obviously, I used animated GIFs, so they're not going to PDF appropriately. So there's a folder in there as well with all of the images and animations that you can download. I've named them appropriately, so it's like vgw.gif is going to be for the virtual gateway, LNG, those kinds of things. So you can review that configuration as well. Again, the tutorial link that was earlier, if you go to Cisco U, search for ENCC, there's a free tutorial again. So that's the same steps that I've used here, but you can reference those as well. Let's go back here for a second. So we've applied that templated configuration, and if all goes well, we should be able to do show crypto IPSec. So we have our phase 1 connectivity, again, to our cloud VGW that we created earlier. Show crypto IPSec SA. So we're seeing phase 2 as well on our VPN. And if all is going to work okay, we should be able to do... Take my word for it, the BGP is up. It's VPN back over half the world. So the BGP is up, and I'll show that if I have some time. Lastly, please fill out your session surveys. I really love the feedback, good, bad, otherwise, of what I can do differently to make these sessions better for you. Fill out a number of surveys, and you get 4 session T-shirts. If you're interested in learning more about our cloud certs or any of our offerings, we have our cert wall back there with all of our different tracks and paths. We have demonstrations of Cisco U over there in the back. If you're looking to get more into like just general network simulation, we have demos of CML. We'll be around all the time. So if you have any questions, please come find one of us. We'll be more than happy to answer. Lots of learning out here. We've got learning at certifications. We've got Capture the Flag. We've got DevNet. We have all of our other stuff. And this will be available on demand and through YouTube as well. And if you have not explored Cisco U, that's a QR code for Cisco U to take you there. Free account. You get access to tutorials and a bunch of free learning, as well as our rev ups for CE credits. And thank you.